Hey, Jam, have you ever wanted to ask an expert a bunch of questions?
I have. In fact, I get to do that specifically with you once a month or whatever, but if only there was another expert we could ask.
If only there is. Well, guess what? Welcome to a bonus episode with Claire, where we're going to ask Claire a bunch of questions following up her expertise episode on how antidepressants work.
Mm-hmm. So if you haven't listened to that one, these questions and stuff like that might be interesting to you, but definitely would be even cooler if you get that foundation. So go listen to the most recent episode that we have about that, and then come back here for the bonus extra questions and stuff.
And while you're at it, go listen to our episode about Adderall from even further back, and then come back here.
Okay, let's do it.
Let's do it.
All right.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
The podcast helps you understand the chemistry of your everyday life. Bonus edition. And remember, this is Claire.
Hi.
Remember from earlier, before this little intro song, this is Claire.
Okay, well, normally Jam asks questions, but these are all questions that I wrote down.
Yep.
We haven't had time to hear from our listeners yet, so maybe we can have Claire back to answer all of y'all's questions. But these are questions that I thought of and that I felt like y'all might have as well. So just to start with, Claire, can you tell us a little bit about like what your grad school experience has been like?
Of course. I simultaneously love and hate grad school, which if whoever has been in grad school could probably say the exact same thing.
Yes.
It's like I'm doing what I love. My passion is science. Like I love science. And I love biomedical science. Technically, my PhD is in biomedical sciences with a concentration in pharmacology and neuroscience.
Okay.
So our grad
Your PhD
school
program.
Yes, my PhD program. And we are a PhD program at a med school.
Which is so cool.
It is really cool. And it's a lot different because we are solely focused on biomedical research. So all human related diseases. There are some labs that do like bacteria and stuff, but it's related to human like pathology.
Got it.
So grad school, I was really excited because I love school. I love being in school. I love taking tests. Like it's just something that comes very naturally to me. But I don't think I was prepared for how intensive it was and how like the jump. Like I feel like the jump from high school to college can be sometimes like it's like okay, like the high school teachers are like college is gonna be so hard, and then they're like not that bad.
Right.
Yeah.
They kind of make your expectations really high to get you prepared for it, and then if you actually heeded their warnings, then you might be like, oh, it's not as bad as I thought. Yeah.
I feel like grad school is the opposite. I feel like no one really told me like how intensive it was going to be, especially the way our program is designed, which I simultaneously love it. And I also didn't like it because it was very like tough. So our first semester, we took 4 classes that were 4 weeks each simultaneously. It was biochemistry, cell biology, genetics, and then just physiology. Like we did pharmacology, a week of pharmacology, a week of immunology, a week of anatomy and physiology.
I just sent off one of those DNA tests. Will you tell me? Can you tell me when I get it back, like what I am and who am I?
Who am I?
But you took
I forgot
class.
everything about genetics. But so I loved the classes, but we had a test every single Friday. So it was like we had classes for 3 days, and then we had a TA review session, and then we had a test. So it was very exciting because it was a lot of classes I already taken before. So it was like just kind of a little bit was review, but it was going really deep, and it was kind of insane, just like the pace at which we were going. So again, I loved it, but then there was like my other classmates, some of them were like struggling because they had never taken biochemistry before. Meanwhile, I just took biochemistry last year, so I was chilling. So while I didn't like that part, it also helped me get closer with my classmate, my cohort, especially those that also went into pharmacology and neuroscience with me. The discipline. So what we did is all of the PhD students that came in that year took all of those classes together. Then the second semester, we all went to our respective disciplines that we chose. Then the second semester, I took a pharmacology class and then a neuroscience class because my discipline is pharmacology and neuroscience.
Yeah.
And those were tough. Those were tough. They weren't as tough as having a test every week, which was really nice. But balancing that with now I had joined a lab officially and having responsibilities in the lab to do research, even though there weren't a ton of responsibilities, because my supervisor knows that I am a first year student and I have like school to do.
Yeah.
It was just a lot to balance that I didn't know how to, and I didn't know how to balance like hang out with my friends that were not in grad school. Mm-hmm. I hang out with my friends in grad school that I have very luckily made because we were all doing the same things together. I saw them in class, saw them studying, saw them in the lab.
Yeah.
So it was hard to balance, but I think I've been very blessed with the people in my department. Are very, very kind, especially the chair of my department. Shout out to Dr. Sumian. She's the best. I love her so much. She really like has worked to make like our cohort have like a really good time and like how we feel heard, which I don't think can be said for all grad schools.
No, it cannot. And that's my job right now is to study chemistry programs specifically, but a lot of faculty, I interview faculty all the time, and they talk a lot about how not for the students other people in their department are.
Yeah. And pretty much all the professors in our department are for the students. I can't think of one that isn't.
So that's
which is saying
really good.
something. Yeah. And it was also really cool because all those classes, our pharmacology and neuroscience classes, they were taught by multiple professors. I don't know is that also how it was for you too?
So the one class by multiple professors?
Yeah, like my pharmacology class had 14 lecturers in total.
No, that's so cool.
It was so because it was like we were bringing in experts of different things. Some people took over some topics that weren't necessarily their expertise, but they were like, I've worked with this before.
Yeah.
Especially for our pharmacology class, which is like we covered diabetes, we covered heart stuff. So like we're a pharmacology and neuroscience department. Like not everyone's going to have like heart expertise, but there were people that were like, oh, I've worked with this before, so I can teach it.
Yeah.
Or I taught this for 10 years. I can teach it.
Yeah.
So that was really good. And I think the way that like that setup works is really nice for my grad school. And I think it's for the students.
Yeah.
So I think I really have been blessed that I go to a grad school that is for students and really works for the education and the improvement of and the success of students.
Yeah.
And has made it's not an easy path, but it's not been difficult in ways that I've heard other grad programs be.
Yes.
So there is hope for those wanting to go to grad school. There are grad schools out there. There are programs out there that are student focused, and it's not the like hell that some people make it out to be. But for some people it is, and I don't want to negate those experiences. But I've been really blessed, and just a tidbit is to make friends in your grad school.
Yeah.
Scientists tend to be very introverted. I just know that I'm not introverted.
I was gonna say,
not me.
I know 2 scientists right here that are very social people.
What?
Yeah, what are you talking about? But even just finding like 1 or 2 people to be like a support system that know the grad school experience, especially the one that you are specifically going through, has been so helpful and has been really what has really pushed me through in like a way that I've been able to be successful. So
nice.
Well, thanks for sharing that. I
That's
thought
awesome.
it might be helpful to think about like, okay, so they've heard about my grad school experience. We had classes and then, qualifying exams after 2 or 3 years. And then I went into more research. But like your experience where the classes were so fast paced.
Yes, and I just took my qualifying exam this summer. So we take it after year 1.
After year 1. Yeah. And having like, then you're feeling like, oh, I have all these classes. And then you go into your specialty. That's a little bit different. And so I thought that would be good for people to hear. And then also I know that we have a lot of listeners who are in their undergrads working in chemistry or pre-med and who I think feel like, oh, I'm interested in medicine, so I must need to be a doctor, like a medical doctor to treat people. But this is another area of science that I don't feel like gets talked about very often. Neuroscience and pharmacology are not things that I learned about very much in my undergrad, and it's not something I hear my students talk very much about. And so I feel like that's a kind of program that could be really fun for a lot of people. So I want to highlight that.
Yeah, and you can work, because I work with an animal model. We work with rodents, but there's other professors in our department who work with human subjects and doing interviews and doing human trials, doing clinical like pharmacology trials. So there's such a like wide range of things you can do that are in medicine that aren't med school. So there's options.
Very cool. Okay, my next question is, what is that tattoo on your wrist, and did you get it for our podcast?
I don't know. There we go. I can kind of do this. Does it work?
Can you
Kind of
see
it? I don't know. I
Might
have
be
to
hard.
twist my arm.
Yeah, wait. Yeah, it's kind of hard. I think we can kind of see there, and I'll zoom in on it as much as I can.
We'll
You
zoom
can envision it if you know the Come For Your Life logo, because it's basically that, except there's bubbles coming out of it instead. I got this when I was a college freshman because I was like, I love science, so let me get a beaker on, on my wrist.
But that's actually an Erlenmeyer flask, not a beaker.
That's true. Dang, you got me there.
Got her.
But when she was a freshman.
Which is funny because when people would say, hey, it's a beaker, I'd be like, actually, it's an Erlenmeyer flask.
Yeah, yeah.
I knew you knew the difference. I knew you did.
But she got me.
Yeah.
She got me lacking.
We used to have, our logo used to be a little test tube, and it had bubbles coming out. And then when we simplified kind of down more, it made it a little easier to like put it on different stuff, on merch, stuff like that. Then we do it into a flask. But no bubbles. So it's like we almost did
so it's
have
like
the
combined.
Yeah, we almost had the exact same thing, but not quite. Yeah.
So it's fate that I'm here today.
Absolutely. Yeah. It's kind of like the White Rabbit situation in The Matrix. Have you guys seen that movie?
Yes.
I don't remember. Apparently I've seen it a number of times and I never remember
I remember one of the first times I met Claire, I noticed your tattoo and I was like, what the heck? Like, it looks so much like our logo.
Yeah, it's green. Like, it's the same green and everything.
Exactly.
Yeah.
And then, anyway, it was so funny. And also, it was great that you stuck with what you started studying back then. And you got, it's like, it fulfilled self-fulfilling prophecy.
Yeah, my dad was like, you can't change your major now. And I was like, no, you're right. I'm stuck here.
If anyone should have that tattoo, I feel like it's me, but you out chemistry for your life to me.
I did.
Okay, next question. So this is into the meat of the thing. In the last episode, you talked, about all these things. What causes side effects?
So there are several kinds of things that can cause side effects. So we know that drugs work at a receptor. So they bind to a receptor. We talked about them binding to a receptor on a neuron. And this itself can produce side effects. So if you have too much of the drug producing a response, it's going to produce like too much of a drug in in the brain. It's going to start producing responses that you don't want. I have an example. The monoamine oxidase inhibitors that I was talking about. It inhibits the breakdown of dopamine. So that means you have more dopamine.
Right.
One side effect of MAOIs could be hallucinations. Hallucinations are caused by excess dopamine. So by inhibiting this degradation, you are increasing the dopamine, making it do things you don't want it to do because there's so much of it.
Right.
That makes sense.
Yep.
Drugs can also bind to multiple different kinds of receptors that have other effects other than what you want. We call these off-target effects. So I think I have an example in my sheet. Let me find it real quick. Okay. Talk about tricyclic antidepressants. So those inhibited the reuptake of serotonin. So serotonin stays in there. They also bind to histamine receptors and acetylcholine receptors, which those are both important. Histamine is actually a neurotransmitter, works in your brain. Fun fact. Very important for your wakefulness and sleep cycle. So do you know why antihistamines make you sleepy? It's because they cross the blood-brain barrier and disrupt that cycle.
I had an antihistamine that made me so sleepy.
So the non-drowsy versions can't get into the brain, and that's why they're non-drowsy. I'm sure some a little bit gets into the brain, but not enough to make. Yeah. Actually, that might be wrong, but the non-drowsy ones like don't have the central nervous system of the brain effect. But TCA, so they're inhibiting those, but they also activate those receptors. So that's why you can kind of have this like dizziness, confusion, because it's acting at these systems that are contributing to like your wakefulness, attention systems. So that's another reason. That's another way that drugs can produce side effects. So yeah,
very cool. The other thing I thought of while you had been talking earlier was how like they can kind of go anywhere.
Yes, exactly. So you don't just have like serotonin receptors just inside your brain. You don't have dopamine receptors just inside your brain. There's serotonin and dopamine receptors in your gut. There's probably some other places. There's dopamine receptors in your cardiovascular system. This was a question that I got wrong on my oral qualifying exam. Because I think I said that they were on the arteries, but they're on the veins. I can't remember, and I'm sorry to my professors who corrected me, and I didn't remember.
That's the level of detail you have to have in grad school.
Yes, it was kind of my fault. Like I brought up the topic when I shouldn't have, because
it was say less.
It was very risky, and my professor asked me. He was like, "So you said this about dopamine? Like, are you sure?" And I was like, I looked this up. I'm not sure. You're right. I don't know. And I felt bad because they were trying to get me to like the point where I was right, but I like couldn't get there. And I was like, I'm sorry. But so again, there are like a side effect of these serotonergic drugs, which just increase or they like modulate serotonin levels. A side effect is constipation because there are serotonin receptors in your GI tract that are contributing. So when they bind, or if you're like causing more serotonin to be out in your gut because you're like decreasing the reuptake of serotonin, then that's going to cause constipation. So that's another reason that side effects can happen as well.
Got it.
I feel like though you did just hit on two very important things about grad school, which one is always admit when you don't know, because your professors probably do know. And they know that you don't know.
And they like it when you say you don't know.
I've seen someone try to BS their way through an oral qualifying exam. It didn't go well. They started crying. The professors dug into them. But if you're just like, I don't know, it's fine.
Yeah.
The other best piece of advice I have is say less. In your writing, in your papers, nobody wants to read all that. Say less. The less you say, the less you have to edit. But if you bring it up, you have to explain it very well. In your exams, anything where you can say less, say less.
Thankfully, that was one of the only things that I got tripped up on. It's just, I even said it in the exam. I said, that was on me for bringing it up. I was like, I'm sorry. That was my fault. And they were like, that's okay. We can move on now.
Nice.
Okay,
so another question is, why do we sometimes have those side effects if we stop suddenly? Like if you are taking an antidepressant, they say, don't just suddenly stop without a doctor's or whatever.
Yeah, so this is like withdrawal symptoms. So... You have a lot of people think when they think of withdrawal, they think of like abused drugs. So it's like you are taking like cocaine or something, and you stop taking it, and all of a sudden you're having cocaine withdrawals. It's really that you're just removing like the drug from your system in such a way that it's like disrupting everything. It's like, whoa, like your body's like, whoa, my gosh, like it's not just something that like waned naturally off. It's like, oh my gosh, now all my processes are like getting reversed and everything like that. We were taught that like withdrawal symptoms often look like the opposite of what the drug did for you. So trying to think of like for SSRIs, like a common side effect that I had when I didn't take it was I was very like drowsy. Like I would get like, if I didn't take it for a day, I would be very like loopy. I would feel very weird. And I think like SSRIs are contributing to this, like, you're being more awake, you're being more attentive because you're not like as depressed. So when I took that away, it's like, oh my gosh, like now I'm back to this like loopy and not as attentive state. And it's because I like suddenly took it away. Like the levels of neurotransmitter or the drug have been so drastically altered that it gets kind of funky. Like the function of the drug gets weird.
Sorry, I'm yawning. It's pretty late. It's like 11:30 p.m. The sacrifices we make for y'all.
For science.
Chemistry, neuroscience at night.
Neuroscience after dark. Okay.
No parents allowed.
So get out. You're the only parent in this room.
No parents allowed? Do you mean no kids allowed?
No kids allowed.
Yeah, I don't know what I meant. I think I was thinking of myself as a kid and being like, yeah, mom and dad are we can play as much video games as we want. Like I regressed.
No parents. You forgot that you're the parent.
Yeah, I forgot. Yeah, exactly. Yeah, that's my life.
Okay. My next question. This is a selfish one because I take Adderall. So is Adderall addictive?
It sure is addictive.
Oh boy.
But it might be a little bit different for you than it is for other people. So this is what I learned in my class, and I looked up a little bit of stuff too. About when I was talking to Melissa, we were talking about that like ADHD. It's just not very well understood. A lot of these like brain disorders are not very well understood. It's just kind of hard to like pinpoint the exact mechanism. But like in your ADHD episode, you talked about ADHD being caused by like a lack of dopamine, which makes total sense. Like You need dopamine for all these like executive functions, like making decisions and being motivated to do things. Like, so not having dopamine would mean you can't do those things, right? Well, what we learned in our class and in a 2008 study in the Journal of Neuroscience, there were 2, now these are male children, so that kind of like adds a little bit of caveat to this. Their dopamine transporters worked in reverse. So remember, our transporters take back up dopamine. So in these children, their dopamine was getting pumped back out when it shouldn't have been. So there was they might have not had like they might not have had more dopamine necessarily. They just had more dopamine in the synapse when it wasn't supposed to be there.
Got it.
It was supposed to be being vacuumed up, and instead it was getting spit out.
It's getting like spit out.
Wow.
Exactly. And in my mind, that does make sense because dopamine is needed for the initiation of movement. And so when you have excess dopamine, you get like kind of jerk, like you can get kind of jerky, and that's very like someone who has ADHD. I think of like a schoolboy having ADHD. They're very like all over the place.
Yeah, there's like the inattentive type and the hyperactive type.
Yeah, so this might be just for the hyperactive type, but it may be also for the inattentive type. I don't know. So interesting. And again, both things might be true. Also, this might not. This is like a gene variant. It's like a mutation. Could just be in not every ADHD patient. So the pathology might be different between every ADHD.
How did they find that out?
I don't know. I should look into that study more. I thought it was interesting. Yeah. Well, what's interesting about amphetamines, which is what Adderall is they reverse the dopamine transporter. So they cause dopamine to be put back out, right? So in these variants, or if like other people with ADHD have these variants, it would just set them back to normal because they're reversing the reverse transporter. Oh my God. I know. It's like,
this is mind blowing.
But in like quote unquote normal people, or someone who has like a normal dopamine transporter, this amphetamine is causing this dopamine to get spit back out into the synapse, which can be it's rewarding, like in the reward pathways. So I think for people, I remember seeing this Reddit post like 5 years ago, talking about how someone was like at a party and everyone took Adderall and they were going crazy because they had more dopamine in their synapses, but they were fine. And they were like, that was when I found out that I had ADHD because it didn't work on me. So I think Adderall would be addictive for people. So remember I said that all drugs of abuse increase dopamine in the reward systems.
Right.
Adderall is a drug that does that. So it is addictive, but it may be just addictive for people who have normal dopamine transporters or don't have ADHD.
Yeah.
So I think for you, you're fine.
Yeah. I recently, my sister sent me and another friend like a meme that was like ADHD or like Adderall, one of the most addictive substances, which I didn't know if that was true or not, but I can't remember to take it ever. And I was like, that is it. It's like, it is supposed to be so addictive and amazing. And it's like, I have to be like, okay, now get out of bed. And you're gonna get your Adderall, and then by the time I get to where the Adderall is, I've forgotten that that's what I was doing. I'm like, is this supposed to be this like really good drug? But I can't even remember to take it.
Yeah, so maybe it's just because since you have ADHD, it's not as addictive for you.
That is so interesting.
Yeah.
That does give me some relief because I have wondered that, like, am I being addicted to this?
And I don't know how addictive it is, like compared to like other drugs. I know like nicotine is one of the most like addictive substances. Just from like we were talking about like how many people out of like nicotine users like get an addiction compared to like other drugs. So I don't know where Adderall falls in that, but I'm sure it probably has a pretty high abuse liability, which means it's pretty likely you'll get addicted just because it directly like increases dopamine in your reward system. Wow. So yeah, fun fact.
That is a fun fact.
Yeah.
Okay, thanks for sharing that. That was so good. Okay, the last question. I've actually asked this question before, but I loved this so much that I really wanted y'all to hear the answer. So I had horrible stomach problems, like indigestion so bad that I had to eat like several times after every single meal, no matter what it was, whenever I was like, before I was treated for ADHD. And it sort of like happened when I was really stressed. So I thought it was stress related. And then like, my Adderall solved my stress problems. I got on antidepressants. Like, okay, so I'm in a much better place. So that's why this isn't happening anymore. But then I went off medicine one year at Christmas because I was like, I don't want to work. I'm just going to be my crazy ADHD goblin self. And the stomach pain started to come back. And Mason, my husband, actually was the one who connected the dots. And he was like, listen, you're acting just like you did before you got treated. And I think you need to take Adderall. And I was like, you're crazy, but sure. And I took it and it stopped my stomach from like burning. And I have not had to take a single Tums since. Like, it was like immediate fix the problem.
Wow.
And I asked you that question. Yes. It's amazing, right?
Yeah.
And I asked Claire about this one day just randomly at church. I was like, this happened. Do you know why? Since you're like a drug wizard. And she gave me an answer that I thought was so interesting. Do you remember what it was?
Yeah, well, there, like I think I mentioned this a couple minutes before, but like there are dopamine receptors in your digestive system.
Mm-hmm.
And I'm sure I don't know if they're dopamine transporters. I'm sure there are dopamine transporters inside because that's what Adderall does, right? It's like reversing these transporters. So I'm sure Adderall it's like the side effect. This is a side effect of Adderall, but it's a good side effect. Like, it's not adverse is what we call adverse side effects.
Yeah.
This is something that it's like, oh, this is good. I like this.
Yeah.
So it's probably working on those dopamine receptors, or it's like increasing the dopamine in your GI tract so that it can work on dopamine receptors to facilitate probably the stomach problems going away. That's my guess. Not entirely sure, but those are those off-target effects that are working for your good this time instead of for your bad.
When you told me that, I was like, that makes so much sense. If the ADHD is caused by the dopamine in my brain not acting right, then my gut problems could be from my dopamine in my gut not acting right. And then I was like, wow.
Right. And maybe they're connected, maybe they're not, because not everyone who has ADHD has stomach problems, I'm sure. Right. But there probably are more people that have ADHD with stomach problems.
Yeah.
So I don't know how separate the dopamine systems are. I'm pretty sure they're probably pretty separate because of that blood-brain barrier they can't get across.
Right.
But they're probably linked somehow. And probably just like genetics and stuff, like your dopamine itself.
Yeah.
Maybe it's related to that.
Wow.
It's all speculation, by the way.
Yeah.
That's neuroscience off the noggin.
Yeah. That's neuroscience off the noggin.
But it's cool because it's so fun to witness these things happen because like these educated guesses that it's hard to prove and stuff like that, but it's like, oh, there's actually a lot of good reasons to think this. Yeah. Those out there, it's not just like a totally wild guess. It's like when you have knowledge, like Melissa and Claire have, and you are posed the question like that, you can actually kind of come up with a pretty good hypothesis for it. So it's fun to watch. It's like that sounds right, and that it's awesome.
Yeah.
I'm glad it's fun to watch. That was the moment I decided that Claire needed to be a guest. I was like, I think you need to come say that to all of our listeners, actually.
Well, if my professors listen to this and they correct me, I'm coming back on here to correct myself.
We have a standing. I can't tell you how many times.
Thing.
Yeah. There's that we have corrections come in quite a bit, and sometimes it's like it's a normal thing, and we encourage it. And sometimes there's a correction that's sent, and it's sort of like, well, that's sort of right. Let's we'll give you some of that, and then Melissa will have some other information too. So we're all about corrections around here.
Yeah, for real.
100%.
Sure.
Mm-hmm.
Okay, so I wanted to finish the episode with this, but we didn't really have time, so I moved it to this bonus episode.
Mm-hmm.
A lot of times we like to finish episodes with what we call categories, which is like a little area. It's like, oh, in this category, give us your answer. Or sometimes we just say like, what's a happy thing this week, whatever. Yeah. This category, I actually got the idea from one of our listeners, from our Patreon listeners, Latila. So sorry, pause for a brief interruption of doors opening and closing. I don't know if you could hear that on the recording or not, but okay. So we got this from Latila, one of our Patreon supporters and listener, and she's become one of our friends. She has a background also in science as well, right?
Mm-hmm, mm-hmm.
She wrote in after our episode about old people smell.
Yes.
And she said that she was like, oh, you talked about the smell of books, like libraries. We love the smell of libraries. Yeah. And she said, you mentioned the smell of books, and I remembered a fun fact that lives rent-free in my head. The smell of books is vanilla with an almond finish. The odor is created by the breakdown of cellulose and lignin two components of paper. It's what give old books their smell.
And
I was like, this is amazing.
Oh.
Then Latila said, she went on to suggest that this be a category that we finish an episode with. And I was like, I'm saving this for the episode with Claire.
Yes.
So the fun fact that lives rent free in my head lately has been that one that you just shared about Adderall. That's my fun fact that lives rent free in my head. But also, I got so excited about this that I started to ask listeners for fun facts that live rent free in their head. And it blew up so much that we're going to have another episode where we play a game where we look up if those fun facts are fact or fiction.
Nice.
But so I wanted to finish this episode with a category of what is a fun fact that lives rent free in y'all's head.
Okay. You go first.
I go first?
Yeah.
It's the only one I can think of. It's a little bit morbid. But it's also kind of hopeful. It's like a 2-part one.
Okay.
I'm thinking about that because we talked a little bit about alcohol and it like sparked this fact. But a third of Americans don't drink alcohol at all. Which I'm like, that's more than I thought.
Yeah.
Yeah. That's
But
more than my sample size.
10% of Americans drink an average of 76 drinks a week.
Oh my
An
goodness.
That's over 10 drinks a day.
76 divided by, 7
Yeah.
is 10 point,
Yeah.
almost 1.
So 10%.
10% of Americans drink 76 drinks a week.
Wow. Oh,
Those are the
gosh.
binge drinks. I know, that's very morbid.
Yeah.
And I don't know why. I was talking about this with a friend earlier this week, and then we talked about alcohol. I'm like, did you know? 10% of Americans. Yeah. So, but shout out to you, third of Americans who don't drink alcohol.
Yeah.
Yeah.
I recently discovered alcohol-free gin, and it's really tasty. But my roommate says it just tastes like a Christmas tree in a bottle. But I like very floral, botanically drinks, so it kind of gives me that vibe without all the negative side effects of alcohol.
Nice.
Because there are tons.
There are
of negative
tons.
side effects of alcohol.
Yeah. Okay, mine's not morbid. And it's like rent-free in the last like 3 or 4 weeks. Okay, so like that's kind of tough because it's not like it's a fun fact I've known for years or something.
Okay.
But I've thought about this many times since I heard it like 3 weeks ago. Because I've been doing some stuff in my yard, trying to, change out the plants growing in my front yard, all kind of stuff. So I've been moving hoses around, which has made me think of this fun fact that I got from a YouTube video. It's like a math physics YouTube channel. And we can link that video to get credit. I need to find it and figure out who it was and stuff like that. But we can link that in the show notes. But the statistic is, imagine that you have or whatever the math answer is. Imagine you had a rope literally going all the way around the earth in like a perfect straight line. Obviously it curves, but like all the way around and comes back and ties together.
Okay.
And so it's laying on the ground. And then imagine you suddenly like, oh, you know what? I actually want the rope to be a foot off the ground everywhere. So I need there to be more rope, right? So in order for it to be perfectly like the same distance, a foot off the ground, all the way around the globe, I need to add some more rope. What would be your just guess about how much rope you need to add?
Couple miles, probably. I don't know. But then that makes me think, I'm like, it's probably.
I think that's a great guess. What do you think?
5 miles. That's all.
I thought it would double it for some reason.
That seems also like it makes a lot of sense, doesn't it?
Yeah.
Do you know what it really is?
What?
It's like 6.8 feet.
No.
I know. It doesn't seem like it should make sense, but the math he showed her the math.
I wonder how he got to doing that, like math.
Yeah. I mean,
but I love it. I'm glad that he did because that's so interesting.
And he did a similar thing for like, if you did the same thing for a square, it makes a little more sense to us to look at a square. So he showed like, if the earth was a cube, what you would do, and it'd be more obvious how to get that extra. And you can kind of like measure how much extra is needed. But yeah, so like it's like something like 6.8 feet. So you take that stretch of rope and untie, add that 6.8 feet in, tie it back, and then it could be raise a foot across the whole globe.
No.
Is it not like mind blowing?
I just like can't figure out how that's true.
I know.
It must not. I'm just kidding. I need to watch that video.
Yeah. Did you run it by our math whiz friend Ethan?
I will. That's a great question.
Because here's what happened. Oh, sorry. Go ahead.
I was gonna say I think it's a high profile in a video that if it was incorrect, it'd be like
somebody would have called it
absolutely destroyed it, eviscerated. Like yeah. Anyway, so but that's a good. We should because he also might be able to explain it a little bit more.
Yes. Yeah. that's something that I learned, and what started this game is people would send in these fun facts, and I was like, I can't share these on a podcast where I'm the expert unless I verify them. And so I started to look all of them up, and sometimes they weren't true, and sometimes they were like sort of true, and sometimes they were just wrong. So that leads us well into next week. Come back for a new segment that I like to call Fun Fact or Fake Factoid. So that's what we're going to be doing. We'll wrap it up, and that's what we'll be doing for next week's episode.
Nice. Usual closeout?
Yeah.
Okay. Your questions, your thoughts, your fun facts. We love hearing those, so send those to us. If you have any thoughts or questions about any usual chemistry stuff or in response to these 2 episodes so far with Claire, send this to us on our website at chemforyourlife.com. That's chemforyourlife.com to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, you can join our super cool Chem community of patrons on patreon.com/chemforyourlife. You get perks, you get behind the scenes stuff, you get fun stuff, you get to know us better, we get to know you better, and also you get an ad-free version of the show. You get some exclusive bonus episodes too. So great stuff as a way of saying thank you for supporting the show. If you're not able to do that though, then you can subscribe in your favorite podcast app, rate and write a review on Apple Podcasts or Spotify, or subscribe on our YouTube channel. Those things help us to share chemistry with even more people, help the show to be discoverable by people wanting to learn about chemistry.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson and Claire Caballero. And Jam Robinson is our producer. This episode was made possible by our community, our supporters on Patreon. And it is so amazing to us that you want to help make chemistry accessible to even more people and that you want to support our show. So we want to thank each of you individually. So thank you to Jesse R., Sierra L., John T., Avishai B., Bree M., Brian K., Carol R., Chris and Claire S., Chelsea B., Derek L., Elizabeth P., Emerson W., Hunter R., Jacob T., Christina G., Katrina H., Latila S., Lynn S., Melissa P., Nicole C., Rachel R., Sarah M., Stephen B., Suzanne P., Timothy P., Venus R., Erica B., Cullen R., and Jeanette N. Isn't it amazing how long that list has gotten?
Yes.
I feel so very honored by all of you willing to join our community and support us. So thank you again for everything you do in that way to our community. And an extra special thanks to Claire for coming on and being our guest expert this episode.
Thank you for having me.
And yay, neuroscience!
Yay, neuroscience!